Hey, welcome back, Mr. PL. So Precal, this is once again Unit 4, Topic 3, Lesson number 8, the last one on Demoivre's Theorem. We're going to start off with a video that goes over the same topic we did in the last video, which is the product of two trigonometric forms. So we have 4 and the 5 are the two radius, so you're going to multiply 4 times 5, and then multiply that by cosine of 3 pi over 2 plus 11 pi over 6, and then plus I times sine of those exact same two angles. 3 pi over 2 plus 11 pi over 6. My pi's and my 11's throwing me off there. Okay, so I'm going to first add up these two in the insides, make them both 6's, so that becomes times 3. Sorry, times 3 makes this 9. So 9 pi plus 11 pi makes 20 pi over 6. Now 20 pi over 6. 12 pi over 6 is all the way around in a circle. So really you're only going 8 pi over 6 more than a full circle. So I'm taking away 6 pi over 6 because that's a full No, that's not a full circle. Sorry, 12 pi over 6 is a full circle. So this minus this leaves me with 8 pi over 6 left over. So this is coterminal to this. All right, so just to get that straight. Okay, so this is, once again, 8 times 30 degrees. This is really 240 degrees. So this is a 8 pi over... Okay, let me reduce this. That's what's throwing me off. So this is 4 pi over 3. So this is 60 degrees more than 180 degrees. And cosine of a 60-degree angle will be 1/2. But you're, once again, all students take calculus. You are in the third quadrant, which is going to be negative. So that's really 4 times 5 is 20 times cosine of 4 pi over 3, once again, is 1/2. It's negative 1/2 because it's in the third quadrant, plus I times sine of pi over 6 would be square root of 3 over 2, square root of 3 over 2, and it's also negative because it's in the third quadrant. All right, and now it's just a matter of multiplying. So this 2 gets canceled out with this 20. That makes 10 on top. 10 times negative 1 is negative 10. And then over here, so let's see, this 3 over 2, this cancels out. That makes this a 10. So this makes negative, that would be I times 10 times the square root of 3. Or 10i times the square root of 3, which is the exact same thing. Either way, there's your answer. All right, so Demoivre's theorem is what you do when you're given a complex equation and you are raising it to a power. So when you're given this, so credit discovered a useful pattern for evaluating powers of complex numbers. So basically we're doing the exact same thing we did before, that z is equal to r times cosine of theta plus I times sine of theta. But what if this was raised to like the third power? Then this is the shortcut of doing that. So basically, so if z is the third power, you raise r to the third power, and then you multiply 3 times theta and 3 times theta here, which you can see right here. So if you make this a 3 and this a 3, this is also a 3 and this is also a 3. And there you have it. Okay, so let's put that to practice. So that would be z to the 4th power is equal to 2 to the 4th power times cosine of 3 times the angle. So that would be cosine of 3. Let me change this to brackets. So 3 times pi over 3, then plus I times sine of 3 times pi over 3, like such. Okay, so the first thing I'm going to do, well, I'm going to do some simplifying. So 2 to the 4th power, 2, 4, 8, 16. So that's really 16 times cosine of, well, this is over 3, pi over 3 times 3. So basically these just cancel out. So it's just cosine of pi plus I times sine of pi. Okay, so now I've simplified it a little bit. Now I can simplify these. So cosine of pi, so remember pi is going halfway around a circle, so that's really negative 1. 16 times negative 1 plus I times sine of pi, that would be 0. So I times 0 would be this. Okay, so now I can distribute the 16. 16 times negative 1 is negative 16. And I times 0 is 0, and 16 times 0 is still 0. So really just this is your answer in rectangular form. And you are done. Let me move myself and do another example of these. Okay, so we have z to the 6th. We're raising everything to the 6th. So that's 4 to the 6th times cosine of 6 times pi over 4 plus I times sine of 6 times pi over 4. Okay. All right, so simplify what I can first. So 4 and the 6 can both be divided by 2. So this is really 3 pi over 2. So that's the same thing for this one. This is really 3 pi over 2 as well. All right, cosine of 3 pi over 2. Now 3 pi over 2 is really 270 degrees. And cosine of that would be 0. So 4 to the 6th power, let me simplify that first. Actually, I'm going to need a calculator for that. That's going to be a very large number. 4 to the 6th power is 4,096. Okay. Cosine of 3 pi over 2, like I said, 270 degrees. Cosine of that is 0. Plus I times sine of 3 pi over 2 is negative 1. Okay, so there we go. Well, anything times 0 is 0. So it looks like there is no real part to this. It's only going to be pure imaginary. 4,096 times negative 1 is negative 4,096i. And there you go, in rectangular form. All right. Now, keep in mind that this can be done, Demoivres can be done exactly the same when you have cubic roots. Actually, I'm not going to do those questions. I'm not going to do rectangular. I'm just going to stick to just polars being raised to powers. Now, I do want to go over one what if, since I'm pretty much cutting this video short here. I do want to go with, what if this wasn't a power of 6? What if this was a power of 1/2? What if it was square root of all of this? Well, you would do it exactly the same way, only square root is the same thing as a power of 1/2. So if I'm going to solve this question, let me get rid of that because that was the same thing. So if I'm changing this 6 to 1/2, you would literally do everything exactly the same. So you would do 1/2, 4 to the 1/2 power, which is 2, times cosine of 1/2 times pi over 4. I might as well actually just do this problem out. I think it actually works out pretty well. Times I times sine of 1/2 times pi over 4. Yeah, actually, I'm going to do this problem. Actually, this kind of lucked out in my favor here. So square root of 4 is 2 times, this becomes cosine of pi over 8. Oh, actually, that's not going to be so easy. Okay, because pi over 8 is not one that we have memorized. So this is, I'm just going to take it as far as I can. So this is really cosine of pi over 8 plus I times sine of pi over 8. And then it looks like I'm going to require some calculator work in order to do this because we don't have pi over 8 memorized. All right, I'm going to stop right there. Thanks again for watching, and have a wonderful day.